These are notes on solving systems of equations. A system of equations is when you have two or more equations and you're trying to find solutions for all of the variables that work in all of the equations at the same time. As an example, y equals 4x minus 1 and y equals negative x plus 4 is a system of equations. What we need to do is find an x and a y value that work for both equations at the same time. We're going to use two different methods to solve the first example. The first way is by graphing. Now this may not be the most efficient method, but it does give you a good visual representation of how the equations work together and what the solution represents. We know that we can graph these using our slope-intercept form. So we have y equals the slope times x plus the y-intercept. So for the first equation, I can start at -1 at my slope-intercept, and then from there show a slope of 4. So I'm going to go up 4, right 1. I can also go down 4, left 1. And from there, I can put in a straight line and arrows on both ends. For the second equation, I'm going to start at my slope-intercept of 4, and I have a slope of -1. So I'm going to go down 1, right 1. And use a straight line to connect them, and put arrows on each end to show that it keeps going. Now these intersect right here at the ordered pair 1, 3. So this is when x equals 1 and y equals 3. Now that solution works for both equations at the same time. So I would say that the solution to the system of equations is either the ordered pair 1, 3, or when x is 1 and y is 3. Both ways of writing the answer mean the same thing, so you can write the one that makes sense to you. Next, we're going to look at how to solve the same system using substitution. When I do this, I'm going to rewrite my second equation as -x plus 4 equals y. I haven't changed anything, I just reversed the order. And then I'll rewrite the first one the same way it is. Now this is just to show you that I can overlap my y values. And when I do that, I can actually eliminate that middle piece. So now I have the equation -x plus 4 equals 4x minus 1. And I can solve that using algebra just like we have earlier in the year. So add x to each side. 4 equals 5x minus 1. Add 1 to get 5 equals 5x. And then when you divide by 5 on each side, you get 1 equals x. Now this is only half of your answer. The other half of your answer is to find out what y is equal to. So you can go back up, pick your favorite equation. It doesn't matter which one. I'll pick the first one. And you're going to substitute in your value for x into this equation. So y equals 4 times 1 minus 1, which is going to give me an answer of 3. So I get x equals 1 and y equals 3. Just like before, I can also write it as an ordered pair. Now notice, this is the exact same answer as what we got using our graphing method. We just did it a different way. So when you're solving a system of equations, you're also figuring out at what ordered pair do the two lines intersect. In this case, it is at 1, 3, and we get that from graphing and from substitution. The next system we're going to solve, one of the equations is in slope-intercept form and the other isn't. So we'll look at how that affects what we do for each of the two methods. For method 1, we can do the graph of 2x plus 5. So start at the slope-intercept of 5. And since we don't have room to go to the right, let's go down to left 1 to show our slope of 2. Straight line to connect the points. And the second line, we need to solve for y so that we have it in slope-intercept form. So we'll rewrite it, y equals negative 2x plus 1. And we can connect the dots to find our point of intersection. So this time our system of equations intersects at negative 1, 3. So x is negative 1 and y is 3. Let's look at the substitution method and see how it changes a little bit when we have them in different formats. This time we have y equals 2x plus 5 in the first equation, and in the second equation we have a y value. So if y is equal to 2x plus 5, I'm going to replace the y with 2x plus 5. All I'm doing is substituting that in. So just like when we had a number that you would substitute in, now we're substituting in an expression. I'm going to bring down everything else, and then I can solve the equation just like normal. So combine like terms, subtract the constant, and divide by the coefficient to get x equals negative 1. Now just like before, I'm not done yet. I'm going to go back up and pick my favorite equation. I'll pick the first one again, y equals 2x plus 5, and it doesn't matter which one you pick. And now I'm going to substitute in x equals 1 into the equation. So I get y equals 2 times negative 1 plus 5. And negative 2 plus 5 is 3. So y equals 3. Now I can write my final answer, x equals negative 1, y equals 3, or the ordered pair negative 1, 3. Let's compare that to the graph, and we got the same answer using both methods. Okay, our next example, we're going to use y equals 1/2 x plus 3. So start at 3, up 1, right 2, or back the other way. And for the second equation, this time we need to divide by 2 on every single term to rewrite it as y equals 3/2 x plus 2. So starting at positive 2, we're going up 3, over 2. Okay, straight line to connect, and arrows on the end. Now this time our intersection is a little bit off of the grids behind it, but we can still estimate that we are at 1 and 3.5 as our ordered pair. So this time we may or may not have an exact value. When we use substitution, we'll find out if that's the exact answer. So I know that y equals 1/2 x plus 3, so I'm going to substitute that in right there. So let's rewrite this as 2 times the quantity. I'm going to put parentheses around the whole thing to make sure that I multiply all of the y value by 2 equals 3x plus 4. Okay, now remember, anytime we have parentheses, we need to distribute. So 2 times 1/2 x is 1x. 2 times 3 is 6. So it's 3x plus 4. Get all of the variables on the same side. Oops, that's actually a 2x. And subtract 4 from each side. And divide by 2. So we get 1 equals x. Now we'll go back up and plug that into one of the two equations. I'll just choose the first one again. So y equals 1/2 times 1 plus 3. So y equals 1/2 plus 3, which does equal 3.5. So our estimate was actually dead on in this example. So I can rewrite my solution. X equals 1, y equals 3.5, or the ordered pair. And that matches up with what we thought that it was based on our picture. All right, our next example has a system x minus y equals 11 and 2x plus y equals 19. Now we can still do the other two methods. We can graph it, we can do substitution. There is a third method that we're going to look at. Now the third method will only work if they're in the right format. This method is called elimination, but it actually is kind of cool in my opinion. With this method, you can actually add or subtract the two equations and have one of the two variables cancel out. In this case, negative y plus y is 0, so that's my 0 pair. So now I can add everything else. 1x plus 2x is 3x. 19 plus 11 is 30. So I get 3x equals 30, which means that x equals 10. Let's plug it in and find out what y is. So 10 in place of x. So negative y equals 1. So when I multiply or divide by negative 1, positive y has to equal negative 1. So that works for the first equation. Let's plug it in to the second equation and make sure that those values still work. Okay, substitute in 10 for x. So 20 plus y equals 19. And when you subtract 20, y equals negative 1. So we proved that it works in both equations. So our final solution, x equals 10, y equals negative 1. Okay, so that's just another method in case graphing or substitution aren't easily done using the format that the equations are in. For our last example, we're going to write a system of equations to help us solve a word problem. It says the difference of two numbers is 3, their sum is 13. What are the two numbers? The word difference tells us to subtract, and the word sum tells us to add. So we're going to set up the first equation to show the difference of two numbers is 3. So we can do a minus b equals 3, and it doesn't matter what letters you use. You can pick. Their sum is 13. So a plus b equals 13. Now again, I could graph these, I could use substitution. Since we've only seen one example of elimination, let's use that. So I'm going to add the two equations together. 1a plus 1a is 2a. Negative b plus b is a 0 pair. And 3 plus 13 is 16. Divide by the coefficient, and we get a equals 8. Now let's substitute that back in. So So 8 minus b equals 3. So b, once I solve it, is going to have to be equal to positive 5. Now as our final step, let's make sure it makes sense in our second equation. Substitute in 8 and 5, and that does actually equal 13. So we know that the two numbers are 8 and 5. And that concludes our notes on systems of equations. Just as a quick recap, systems of equations are when you have two or more equations and you're trying to find values for all of the variables that are equal for all of the equations. If you are graphing it, a system of equations, the solution is also the place where the two lines intersect.